We're going to show you some basics about work offsets using Mach 3. As you can see here in CamBam, we have a simple inside profile cut that's roughly centered around the origin. Typically, the machine is zeroed at this point right here. When we get to the machine coordinate 0 leaves all of the working envelope of the machine to the right and away from this location in the positive quadrant. Well, so we couldn't cut this in Mach 3. I mean, we could move it here in CamBam, but there are some reasons why we might not want to. But we could just move it up here to the area that we know is within the work envelope of the machine. But we may not want to do that. It may be in that location relative to other parts. We may not want to monkey with stuff or change stuff. We may want to work around the origin because it's easier to mirror stuff around the axis at 0 or what have you. For whatever reason, we may not want to just put it at those coordinates in our drawing. We may want to leave it like this in our drawing. Or we may have gotten some cut files from somebody else, or we may be confused. Well, we can go ahead and generate the code, machining, produce G-code. We'll call this one test 1. Alright, and then we'll come over here and we'll load G-code, test 1. Alright. Okay, in Mach 3, you have two sets of work coordinates typically. You have your absolute machine coordinates. See, machine coordinates is lit up in red, and it shows that we're at 0, 0, 0. And if we're referenced to home, and this really is the work area of the machine over here, we obviously can't cut this part. Okay? But we can do is go into our work offset coordinates and tell Mach 3 that 0, 0 is not 0, 0, that instead it's something more useful, like -2, -2. Now you can see that the part will be cut fully within the work envelope of the machine. Maybe we might want to get it a little closer to the origin for whatever reason, because that's the way we set up our part. But in general, it's going to be within the work area of the machine. And as we can see, our machine coordinates haven't changed. The machine hasn't moved. It's still at the absolute 0, 0, 0 coordinates. It's just that we've told it the absolute 0, 0, 0 coordinates for the purpose of this job are -2, -2. That places the job offset to where we are now. We can easily cut this part. Now there's another way we might run into this. If for some reason somebody sent us a code file where it's not close to the origin, it's way out in left field somewhere, say 14 inches off to one side, oh, where'd our part go? It's way over here. Machining, produce G-code. We'll call this one test 2. Alright. Now let's open test 2. Load G-code, test 2. Whoa! We can't cut that. That's 14 inches over, and our table's only 12 inches wide. We've only got 12 inches of workroom. Whatever shall we do? Well, that's pretty simple. We just come in here and we change our relative position. Boom, now it's back within our work envelope again. The machine still hasn't moved. We're still at 0, 0, 0 absolute machine coordinates. But our current work offset is +12 -2, which puts the part we want to cut within the work envelope. Where you normally use this is setting up your machine to zero to the edge of a piece of stock. You'll use a touch probe or a wobbler or some other type of sensor or indicator, or simply dragging a piece of paper between your stock and your cutter to find the edge of the stock. And then you'll be cutting your part somewhere on that piece of stock. Anyway, that's basically it. That should get you started. It's the basics. There's a lot more that you can do than that, but that should explain the basic principle. Even though the machine will cut relative to us being at 12 plus 12 and minus 2, it's actually still at 0 and 0 absolute machine coordinates. There you go. I hope it helps.